Our fifth method to prepare amines is a new method, and this is called a reductive amination. And what it allows us to do is start out with a simple amine and prepare a more complex, more highly substituted amine. Now, what you're looking for to do this reductive amination is a few key pieces. So we need an aldehyde or ketone, we need an amine, and it needs to be either ammonia, a primary amine, or a secondary amine. No tertiary amines. And lastly, we need a reducing agent. Okay, now I'm going to use sodium cyanoborohydride in the presence of methanol. And really all this is a hydride source. A hydride source, and methanol is a proton source. Okay, that's the reagent I'm going to stick with. Now, if you're using the McMurray textbook, you'll see that they use as a reducing agent hydrogen gas and a nickel catalyst, or sodium borohydride. Okay, any of these conditions are fine. I'm just more used to the cyanoborohydride, so I'm going to stick with that, but you're welcome to use any of the three conditions. So what's going on here? We're going to start with our aldehyde or ketone. I'm just going to use this ketone and an amine. Let's use benzylamine, which is this. And then our reducing agent, the sodium cyanoborohydride. Now, one of the nice things about this reaction is that this isn't stepwise. All three of these things are mixed together and the reaction takes place. So what we can do is, just to predict the product, essentially the amine gets attached to where the oxygen was on the carbonyl, and it ends up just being a single bond. So to give you an idea of where all the atoms come from, here's the 5 carbons from pentanone, bonded to that. We have our amine, and then from our reducing agent we get the hydrogen. So what we've ended up with is we've taken this primary amine and we've converted it to a secondary amine through this reductive amination. So let's try to figure out what's going on here. So the first thing you should recognize is that we have the amine and, in this case, ketone or aldehyde. So think back to chapter 19. where these can come together to give you an imine. So that's actually the first step. So we get the imine, and water. Then that imine reacts with the reducing agent. So the hydride from the sodium cyanoborohydride, that'll add in there. And then from the methanol, that can grab a proton. And that's how we get the amine. Okay, now let's think just a bit about this reductive amination in a retrosynthetic sense. For example, if you were given this secondary amine, you want to think about how you could have gotten this via a reductive amination. Well, there's actually two routes. This could have been the new bond, so we'll call that route A. Or this could have been the new bond. Let's first explore route A. We'll use a retrosynthesis arrow since we're thinking backwards. Okay, if that was the new bond, then this carbon must have been the carbonyl carbon. So there's the ketone. Plus the primary amine. That's one pathway. Okay, if we'd prepared this through path B, in this case, this carbon would have been the carbonyl carbon. Which actually turns out to be an aldehyde. Plus, we would have the cyclopentylamine. Both routes are perfectly fine. And really, there isn't one that I would say is any better than the other.